Morning, chemists. What we're going to do today is a lab on halogens, or specifically after they become ions, they're called halides. And so if you guys remember, halogens are group 17. That includes the really reactive fluorine, chlorine, bromine, iodine, and acetine. Those things are considered to be really reactive because they have 7 valence electrons. They all have 7 valence electrons. They would like to get one more really bad. So that means they're going to be really reactive, and therefore they're used as disinfectants. If you remember, fluorine is used to clean your teeth. Chlorine is used to keep the pool clean. Iodine's used in surgery to keep your skin clean. So we're going to look at 4 of these 5. The one that we're not going to look at is acetine, which is at the bottom. That one's radioactive sometimes, so we're not going to bother with that one. How does it get to be a halide? All right. Why is this called halides? Metals tend to lose electrons. Non-metals tend to gain electrons. Well, halogen, being a non-metal, wants one more electron really bad. So if we hook it up with a metal, the metal's going to lose electrons, the halogen's going to gain an electron, and therefore it's be called a metal halide. That's the way we name things in chemistry. So for example, sodium, if we take sodium and put it with fluorine, it's going to react in such a way that sodium is going to give up its electron. It's going to become sodium ion, which is +1. Fluorine is going to gain 1 electron. It's going to become fluoride, and that's going to be F-1. So the ionic charge for all of these becomes -1 because they're all going to gain 1 electron to become full, like a noble gas. All right, so the way that we're going to study these things is by doing different chemical reactions with these things. And so whether you look at your lab, or if you look at the board here, here's kind of the setup. We're going to have the spot plate. The spot plate's a little plastic dish. You'll see that in a minute. And each one's got a little depression in it where you're going to put a small amount of chemicals. You'll be able to see the reaction without having to put it in a test tube. It's going to be easier to see. This is also easier if you put the spot plate against a piece of white paper and look at it under white paper, and then also look at it underneath the black top of your lab station to see the difference in the colors. And so each line going across here, we're going to put the halide. And we're going to use sodium halides for all these so that sodium isn't the issue here. All right. So in the first line, you're going to put 5 drops of sodium fluoride in each one of the first 4 spots. In the second one, you're going to put 5 drops of sodium chloride in each of the first 4 spots. And then sodium bromide and sodium iodide. All right. And then later on, we're going to look at some unknowns, and you're going to do the same thing. So you're going to put in these last 2 rows, you're going to put 5 drops of unknown number 1 and 5 drops of unknown number 2. Now, all of these solutions are clear and colorless because everything's soluble in water. What we're going to do is we're going to add chemicals. And in this first row going down, we're going to add 2 drops of calcium nitrate, CaNO3(2). And we're going to put 2 drops, and we're going to look for any kind of change. And any kind of change would be it not being clear, because calcium nitrate is also clear. So 2 drops in here, 2 drops in here, 2 drops in here. We're going to put 2 drops in every single one. And we're going to save these till later, the unknowns till later, because we're going to kind of use what we see for a key here. And we're going to look for something that's different in these. All right? So you do that, you write down what you see. And then in the next one, this is kind of tricky. If you just follow the board directions, you might do this wrong. We're going to use silver nitrate. That's a really common reagent, chemical that's used to look for reactions. And we're going to put 2 drops in each one of these things. All right, and then write down what you see. Make sure you're not putting in, make sure you're observing this before you do the next thing. All right, so write down what you see. And also, if you see specific colors, be as specific as possible so you can tell the difference between these 2. All right, then in those same spots, you're going to add 2 drops of ammonium hydroxide. Okay, NH4OH, ammonium hydroxide. That's a basic solution. It's going to change it so that it might change what you're going to see. And so you're going to add 2 drops in each one of these, and you're going to look to see what it changed from before when you put the silver nitrate in. All right. In the next one, we're going to also add 2 drops of silver nitrate. So if you wanted to add 2 drops of silver nitrate to both of these when you start, your observation is going to be the same for those. All right. In the second column, you put in 2 drops of ammonium hydroxide. This time, we're going to put 5 drops of Na2SO23, okay, sodium thiosulfate, and we're going to put those 5 drops in there. And again, we're looking for some sort of change that takes place. All right, and then the last one, you're going to have drops of starch and drops of bleach. Now, if you guys looked and you saw this from a year ago, you might have done this lab before last year, or seen an example of it anyway, but this is something you would have done in biology. Anyway, you're going to put 2 drops of starch in each one of the first 4 spaces there, and you're going to look for anything that looks different. And then after that, you're going to add 2 drops of bleach to each one of those. And again, you're going to write down what you see that's different on your lab sheet. All right. When you're all done, what you're going to do is you're going to use this information as a key to tell what unknown you're looking at here. All right. So we're going to put 5 drops of unknown number 1. Unknown number 1 and number 2 is one of the halides. So what you're going to do is you're going to try to match the results here to the match that you see up above, so you can tell what unknown it is. All right, some things to look out for. All right, how is it different in each column, and how is it different in a row going across? Okay, so which ones work for which reagents? Those would be the things at the top. Which reagents would you use to identify fluorine or chlorine or bromine or iodine if it's in there? So these are used to identify which halides that you have. All right, so let's go look at our lab and we'll get that set up. All right, so you guys, what I did is I set this thing up, and I want you to look and see what I did here. I took a piece of paper, a white piece of paper, and I wrote a guide. Now this is my spot plate, and it is 4 rows going this way, and it has 6 going down this way. And so I set it up kind of like what I showed you on the board just a minute ago. And so then I wrote down a little guide on here, the side. Now you don't have to do this necessarily for yourself, but probably setting this against a white piece of paper will be kind of nice. And occasionally you're going to see me pull the white piece of paper away, and so we can look at it against the backdrop of the black, and we can see the different colors that are there. So I think that'd be a good thing to do. All right, so over here I have my sodium fluoride. So what I'm going to do is I'm going to take and I'm going to put 5 drops in each one of these spots. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I'm going to close that up and I'm going to put that one away. All right, in the next row going across, that's where my chlorides go. So I'm going to put sodium chloride, and I'm going to put 5 drops in each one of those. So 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and if we were to look close at those things, we'd see that they're colorless, which is pretty typical of solutions. They're usually clear and colors. So now let's put 5 drops in here. 1, 2, 4, 5. All right, so there's 5 drops in each one of those. And the last one, sodium iodide, has kind of a yellowish brown color to it, and so that's why it looks like this. This is almost more of the bottle being stained than the liquid inside, but we're going to put 5 drops in each one of those spots. So and what I'm going to do now is I'm going to put my unknowns in since I'm doing this, and we'll get things out of the way here. So my unknown number 1, 1, 2, 3, 4, 5. All right, and then my second unknown is going to go in this last block going across. All right, so now I'm ready to do my reagents. So the first reagent that I'm going to deal with here is the calcium nitrate in the first column. So I'm going to put 2 drops in the first spot. 1, 2, and then 2 drops the second one. 2, 1, 2, 1, 2. And at first, it may not look like anything happened, but let's look at that And if I look, I don't know if you can tell, but in this first spot up here, it got cloudy. All right, so there's a white cloudiness to that. That cloudiness is called a precipitate. That's actually a solid. If we let that sit long enough, it would settle to the bottom. So the only one in that first column that reacted is sodium fluoride. So it seems like calcium nitrate might be a good thing to use to identify fluorine or fluorides in a substance, all right? So if you need to pause for a minute, write that down. In the first one, you would write that there's a white precipitate, and then the next 4 down here, you would write NR for no reaction. Pause it if you need to. All right, so in our second and third reagents, we both need silver nitrate. Now, silver nitrate is mildly toxic, so you don't want to get it on your skin. You certainly don't want to eat it. We have to store it in an airtight, or excuse me, a light, seal it from light, because the silver chloride or nitrate will degrade, and it's expensive, as you can imagine. So what we're going to do is we're going to add 2 drops to this one. 1, 2, 1, 2, 1, 2, 1, 2. All right, and then we're going to do the same thing over here. So 1, 2, 1, 2, 1, 2, and 1, 2. All right, and so when we look at this, I don't know if you guys can tell or not from this, but what we did, if we actually got precipitates in some of these. So now, if we look at this with just the silver nitrate in the white, the first two, these two had no reaction at all. There's a white precipitate. That one's kind of a yellowish, maybe yellowish green precipitate. And this one's kind of a grayish white, light gray. Maybe got a tinge of blue to it in there. All right, so write those down if you need to. All right, so now in the second column, I'm going to add ammonium hydroxide, and we'll see if that changes anything. All right, so I'm going to put 2 drops of each in here. So 1, 2, 1, 2, 1, 2, 1, 2. All right, so now if I look at that from before, we can kind of compare it to the one next to it. I don't know if you can tell or not, but when I put those 2 drops in there, this one seemed to fade a little bit. All right, this one, if I look at it, didn't seem to change very much at all. And then down here, that one didn't change either. All right, so this is the big one. This one kind of faded. It's got the white precipitate, but it faded some. And we can kind of tell because we're going to compare it like this. All right, so pause it if you need to write things down. All right, so in this next column, what we're going to do is we're going to add the Na2S2O3. And we're supposed to add 5 drops of each of these. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. All right, and now we're going to look and see what happened to that. Holy cow, there's a pretty significant change in this one. This one up on top had no reaction to it, but this one, wow, it faded a lot. This one faded quite a bit too. This one seemed to have not much of a change at all. Okay, pause that if you need to write that down. And then the last one, what we're going to do is we're going to add starch. And we're going to write down what happens, and then we're going to add some bleach to it. We'll write down and see what happens. So here's 2 drops of starch. 1, 2, 1, 2, 1, 2, 1, 2. And when I look at that, I can see, wow, there doesn't seem to be any kind of change at all taking place there. So write that down. So there's no reaction with the starch. But now I'm going to add 2 drops of bleach. So 1, 2, 1, 2, 1, 2, 1, 2. Oh, holy cow, something pretty amazing happened here. In each one of these, there seems to be no reaction, so nothing changed. And if I take that away from the white paper and put it back there, you can see that those first 3 had no reaction in it. All right, But this one turned black. And if you look at that, iodine's the only one that turned black with the starch and the bleach both in it like that. That would be a good thing to note. All right, so now that we've got that set up, and if you need to pause this and write down what happened, do that. But now what we're going to do is we're going to test our unknowns and see which one's which. All right, so in the first unknown, we're supposed to add calcium nitrate. So I'm going to add 2 drops calcium nitrate to this one and 2 drops of calcium nitrate to that one. And then we're going to see if we got any change at all. That looks like no reaction. So that should kind of help us figure out at least what one of them isn't. All right, so now let's go back to our silver nitrate. We got to add silver nitrate to both of these. So 1, 2, 1, 2, 1, 2, 1, 2. All right, so we did get a reaction. This one's kind of, the first one, unknown number 1, is a white precipitate. This one's kind of a yellowish, maybe yellowish green precipitate. All right, now in this column, we're going to add the ammonium hydroxide, NH4OH. So 1, 2, and 1, 2. And we're looking to see what happened there. Okay, and then in the third column, we're going to add the sodium thiosulfate. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we can kind of see what happened in that one. This one cleared up almost entirely. This one did quite a bit. There's still some left in there. And the last one, we're going to add the starch. So we're going to add 2 drops of starch. 1, 2, 1, 2, and we didn't get any reaction. That's kind of what we expected. And now we're going to add 2 drops of bleach. 1, 2, and 1, 2, and we didn't get any reaction there. All right, so now based on looking at our results here, you should be able to tell which unknowns were of the 5 up here. All right, so you should have enough information now to go ahead and do your lab. Guys, good luck.